Hey guys, welcome back to Max TV Original. In today's video, I will be showing you how to make professional circuit boards that will last for a long time. So let's get started. So here is the part 1. In this part we're going to have a look at the software and the design on the computer for the circuit board that we're going to be manufacturing. So in this case I'm not going to walk you through the software, how to design it. I'm sure you know how to design it, I'll probably use your own software, but in my case I use the software called Free PCB. It's a free software that you can download. There is no trials, there is no demo versions, it's just a free software for you to use, and I already have a design which I will load right now. This is a switch, which is a button using two tactile, it's a dual switch using two tactile buttons and two MOSFETs. So you press once, the light is on, you press second time, the light is off. If you also press once and the light is on, you turn the main power off and turn it back on, the light will reset to off. Pardon me. So it uses here it's mostly not about schematic, but anyway I'll explain you quickly. So Q1 is the MOSFET, Q2 is the MOSFET, NP, both NPN, VR1 is the voltage regulator, it's got a capacitor, a couple of components, it's got two 555 timers. Those are outputs here, 12 volts in and literally just through some drain out kind of thing, and neutral. So those are connectors for the switches. So most of the components on here are surface mount, and only a couple are through hole, which is those connectors. It's a DuPont, dual DuPont for the switches. One jumper that is a through hole, actually two jumpers, there's two more here, one capacitor that is through hole, and three of those connectors that are through hole. The rest of the components, let me take this off. As you can see, it's all surface mount. Now you don't have to make all surface mount, you can make either everything surface mount, or you can make everything through hole, depending on your complexity and if you're capable of doing surface mount. But in this case we're going to be doing both. So surface mount and through hole. So after you finish your design, which is a really easy software, I know there is a better software than this, but I'm used to it, I like it, I have no problems with it. We're going to export the files. So we're going to click File, Generate CAM files, and here, because we're doing a single-sided circuit board, we're going to generate drill file. We don't need a top silk screen, don't need a bottom silk screen. We're going to generate top solder mask, because we will be, you don't have to, if you don't want to do solder mask, which is a green layer that is a solder resist, you don't have to then tick it, just leave it blank. No bottom solder because it's a single-sided, and top copper, obviously no bottom copper. So we're going to include the board outline, we're going to add Morris, so this is going to be for alignment. Add layer description text, no. Add pilot holes to the pads and vias, yes, we're going to add that. Add thermal reliefs. Thermal reliefs, like in this case, it'll say we have this square here, and it'll just add little spaces here. So when you're soldering, it's not going to take up a lot of temperature and, you know, to heat up the rest of the aluminum, it'll be the rest of the copper, it'll be just that part. In this case, you don't need this circuit board is small, there is no large current contacts, so we're not going to add them. Use thermal relief for vias, no, because we don't have any vias. Make cutouts and a solder mask for vias. Again, if there are vias, you can. You will have to, because you'll have to solder them. So we're going in millimeters, we're going in metric. So copper to copper distance, hole edge copper to fill clearance, usually leave them all blank, except I usually do solder mask clearance 0. This way the solder mask will be following the edge of the copper. If you leave it with any other distance, then it can be the larger or smaller and covering some of it, so I leave it at 0. Then click create files, and it's succeeded. Great. So now that we created these files, you will need another software. Again, it's a free software, it's called Gobert Logix. So that's the software. You will have to register. Again, this is private, non-commercial editions. It's free for home use. So if you are using commercially, you will have to register and pay money, but once you download the software, it'll ask you to register and which purpose are you using it for. If you click for home use, it is free for you to enjoy at home. Again, if you are going to be manufacturing commercially, you will have to pay the licensing. So now we're going to go open and load files, add files, and we go to my projects, click on CAM files folder, and now we have here the drill file, top copper and top mask. So we select all three of them, open and translate files. So now as you can see, it is loaded. So that's those alignments I was talking about. Now because we selected the drill file, if you're using a mill, like CNC mill, to drill the holes, then you will need the drill file and load it into the mill. In our case, we're going to turn it off. I believe it's this one, and you can just see those little pilot holes, so we're going to leave them. And this file also includes our solder mask. So what we're going to do is go to Edit, Transform Layer, and then we're going to click Auto Snap. Oh no, hang on, Transform Active Layers, and we're going to get that menu. We're going to select the top mask, and then we're going to move it to the right. And as you can see, it's moving, so we're going to create two files out of it. So one of them is going to be the copper, and the second one is going to be the mask. So I'll just align those. Perfect. So also, if you are making, we're going to be printing this on vellum paper, so that's all we need using a laser printer. However, if you are going to be printing on transparency film, you will need to load the files again and then make a duplicate and move them down. So you will end up with double the copper and double this. The reason for that is that when you print it, it's better to print two of those on the transparency film and then overlay them over each other, so the light is, so it's more dense and the light cannot penetrate through them, because a single layer, some light will leak through the ink. So in our case, we're using a vellum paper. So now that that's done, we're going to get it in the center. Hang on. There we go. And now we're going to export it as the high resolution picture. So create export picture, create visible, actually complete, high, save as, and we save it to the same folder just so we don't get confused. Picture, and we save it in the BMP file. I'll take a second because the picture is big, so that's saved now. Now let's open the BMP file and have a look. So here we opened our generated images in Paint. I know, pretty basic, but it works and really well. They're in high resolution. So next step we're going to do is go to Menu and Save As. BMP pictures, the same as this, except down the bottom here we're going to select monochrome and save. It'll warn you that you're going to lose all the color and that the picture exists. Yes, replace it. That's a warning about the format. Okay, so now we're going to have, once it saves, black and white picture. Don't worry about it. It may look rough on the edges, but once you zoom in, it's not actually rough. It is just fine, and as you can see, it's perfect. So that's a good also time to make your own little notes if you want to say. So like, for example, in my case, we're not going to touch that part again. The part on the right here is a solder mask. Not everyone is going to be using that. Some people prefer just a bare circuit board without the photoresist solder mask. So in that case, you wouldn't have to generate it or use it. So also this is a good time. We're going to click on text, and just in that corner here, I'm going to type in white. And we're going to move it over just here. That's done. The next step is to select just over, slightly over the size of the board. And then we're going to click right click, invert color. That's inverted. Now right click and rotate, flip horizontal or vertical, doesn't really matter. So I do horizontal. So now we've got a mirror image of that. So now we go to this side and we do almost the same, except we don't flip the color. So we select it larger, right click, and then we click rotate and flip horizontal or vertical, doesn't really matter. So now that's flipped as well as a mirror. So at this stage the image is ready for printing. So we will go now to, we'll save it. We will go to print and go to print preview. So we'll have a look at it, and that does look a bit larger than normal. But what we do is usually print it on the normal film, paper, and then just drop the chip on top of those little, let me show you, why would not zoom in? So anyway, on top of those pads, if the 555 chip fits perfectly on them, then it's right size. Usually they are the right size. Now we're going to click on print, page setup. In page setup, it will tell you that it's a portrait and it's fit to one-to-one pages. We don't want to fit, we want to adjust to 100% of normal size. We can do a horizontal, and if you want to conserve your transparency film or vellum paper, you know, the transparency film is super expensive, so you may want to print multiple. You don't want to waste the whole sheet on just one small schematic. You can leave it vertical off. This way it'll print just at the top, and you can cut it out later and reprint more schematics on the rest of it. So anyway, at the moment we're just printing a test on the normal paper, so click OK. That's what it's going to look like. It does look like a normal size, so click print. Now that we have printed it on the normal paper, we're going to take our little 555 chip, it doesn't matter if it's a through hole or anything, and we're going to drop it onto the solder mask. And as you can see, it fits perfectly. Let me zoom in for you so you can see. You can see the chip fits here just right, if I line it properly. So again, I think it's a bit on the angle. If you're not printing the solder mask, you can always test it on the normal PCB that you're going to be making, just here. And again, you can see it's hard to position it while I'm not above it, but yeah, you can see that it fits and sits here just fine. Where is it? There we go. That means that your board is printed correctly, and you can now print it on the vellum film. So again, you can print it on the vellum film or on the normal transparency film. However, transparency film you will print double. Then once you print double, you cut the first part out and you overlay it over the top, and using maybe a bit of a drop of super glue to adhere them together. So this way you double the thickness of the ink itself. In this case, I've already printed the vellum version of it. As you can see, it is semi-transparent, and that's what we're going to be using. Another reason why you want to put text on there is when you're applying it, as you can see, it's mirrored. So let's have a look at this little text that we've added on the circuit board, which is here, that says Max TV. When you're applying it to the circuit board itself, when we get to that stage, this will help you to position it correctly, because once you apply it to the circuit board, this text becomes normal. It becomes readable as Max TV. If you're doing it incorrectly, then the text will be mirrored. So let's get rid of that. And I think that's it for the step 1. Now let's move into the step 2 of preparing the circuit board and what we will need. This is part 2, where we're going to be making the circuit board or transferring the design onto the blank PCB. So first of all, we grab the blank PCB. This is just a single layer. Again, you can be doing the same with the technique with a single layer, except when you're doing a single layer, the board is always slightly larger. And what I do when you're designing the circuit board, just either use those and make sure that your circuit board is big enough to fit them all. This way you can align 2 vellums. So let's say this is the first one, and then we got the second one. You grab them both, that's the design. You align them perfectly here, so they all match. Once they all match, you just tape both sides. So you cut the side here, and you can just use sticky tape. And then once they tape together, you slide the board in between of the designs. This will ensure that the board will get even design, so obviously you'd tape the board as well. So in our case, we're just doing a single-sided design. So first cut a little piece, where have I lost scissors? I'll use a Stanley knife. Cut a piece of paper just larger than the paper, larger than the board. That's just perfect. Second, we will need a laminator. Just a small or any laminator will do. It's going to be a hot laminator. We will need a blank circuit board. Usually tub of water. I'm not using a tap because I'm at the bench, so usually I would use a tap. So some of this scrubby stuff, the metal, and we start washing the board. Just slightly, don't apply too much pressure. Make sure all the edges are done so there is nothing rough. If there is something really rough, grab a piece of metal or a Stanley knife and just scrape it slightly, even with the back of a Stanley knife, to even out. And you can just feel, don't cut yourself, but you got to make sure that the edges are nice and smooth. Again, the board is going to be just a bit larger than your design. You can trim it later. Make sure there is no rough edges left on the copper side after you're cutting it. Usually I use a simple hacksaw, universal one for metal and wood, to cut the design. So now that that's smooth, continue on. A bit of a dishwashing liquid usually helps. And do not touch the copper surface unnecessarily, because that will leave prints, especially if you're cutting say from a large piece. Do not touch the large piece or any copper, because once you leave a fingerprint on it, within a couple of hours it will darken and start corroding. So again, using just light force, we clean it up in a circular motion. Make sure you cover every single bit of it, and you will see the board will become shiny. Okay, so now that the board is shiny, just give it a quick rinse. And then we will need a spray with the demineralized water. Again, usually I would just use demineralized water and rinse it in demineralized water and dry it, but I'm not at the sink, so I'll use my usual spray. And just make sure that you clear all the dirty and soapy water off the mineralized. Usually I rinse it with the normal tap water and then use demineralized water to get rid of all the soap and everything that's left on it. Okay, so now that it's cleaned, you can see the board is now really shiny. So now we're going to use standard paper towels and dry it up completely. Again, after you cleaned it, do not touch the surface with your fingers. You want to dry it and you want to leave the surface untouched. Dry it as much as you can. And look at that, it is really shiny. So now that that is done, we're going to go to the next step. Put the board aside. And we will need the spray or mist, the finer the better, with the demineralized water. And we will need a photoresist. In this part of the video where we're going to be making the actual exposure to the circuit board, the lights are a bit dim because I don't want to expose the film yet. I've made this orange light that I usually would make this on, so I'd turn all the lights off and I'll leave that orange light on and do it, but obviously to show you I will have to use normal light. So usually you can buy this photoresist film on eBay. It comes as a roll in a black film, so I can't really open it to show you. I don't want to expose the whole roll. That's what it looks like. It's a piece of it. So I've just cut a bit of it. If you buy it, it's probably around $15 to $20 and it'll last you a long time. There's quite a lot of that film there. So let's put that aside. So there's a piece that is perfectly enough for our circuit board. As you can see, it'll cover plenty. So the next step is we're going to grab our circuit board that we already washed, as you can see. Turn the laminator on the hot setting. So this laminator has got cold and hot settings. So put it on a hot setting, get out a piece of paper and just a normal paper and fold it in half like that so it fits into laminator. So now we need a bit of a sticky tape. Just 2 small pieces is enough. And what we're going to do first is spray demineralized water onto the circuit board just so you can create little mist. I'll try to show you on the camera. It's just covered in water. The whole board is covered in demineralized water. Then we're going to take our photoresist film. We're going to find a corner and attach just a little tiny bit of tape on that corner and opposite on the other side. This is the best way to peel it. And then we're going to peel them apart. Try again. There we go. And now we can see that we've got a clear layer and not clear layer. Just to show you, there we go. So don't peel it off fully just yet. Flip it upside down, because if you stick it to itself, then that piece is going to be ruined. And if you remove that, just like sticky tape, if you remove that whole piece, it will stick to itself. So now we're going to apply it on top of the circuit board, on that wet circuit board. And then we peel the rest of it off, just carefully. So we're going to grab a small plastic squeegee available with, you know, your convenience store, and just slightly squeeze the water out. Make sure there's no bubbles. Once you squeeze the most of it out, don't put too much effort into squeezing all the water out, because we will put it through the laminator, and then using a scissors, flip it upside down and just cut the edges roughly. Make sure you dispose of those cut-offs, because if they get on your floor, they will get exposed and it would be a nightmare to get them off. Trust me, I know, I've been there. Those cut-offs will expose themselves later, sooner or later, and you will end up with a big mess. Now that we've done that, we're going to take our piece of paper that we got earlier, put it in the piece of paper, and stick it through a laminator. Usually I help with scissors or something. Just put it inside there and just help it to get sucked in. Once the laminator takes it, that's fine. Let's go to the other side and wait for it to come out. Now that's done. All right, and let's have a look at it. And as you can see, this is perfect adhesion. There is no bubbles, there is no nothing, it's just perfectly laminated. Now let's put it upside down and put it aside while we clean up. Always store your board freshly laminated, either in a black pouch. If it's daylight, I do my stuff at night, but always make sure if you're putting it aside for whatever reason, you need to clean up or get ready for something else, always put it upside down onto some flat surface. This way it doesn't get exposed to the light. So now, after we've laminated our board, I'm going to keep the lights away from it. We're going to use a transparency film. Do not use the vellum paper. I've tried it, it is horrible. So the best way to do it is to print 2 copies of transparency film and then stick them together. So this way you have a very, very dense black color. So I'm going to apply it over the board. It is quite a big board. I can probably fit 2 boards onto that actually, if I try. But anyway, we're going to fit that right in the center here. And we're going to put it in our UV exposing unit and set it on the first setting. The board has now been exposed with our new UV exposing unit that we've made in the previous video. So let's get that out. And as you can see, if I can get that off, it's been really compressed. Yes, it is perfect. The next step, we're going to put it in a developing solution. So let's talk about the developer solution first. What I've done is you can buy ready developer solutions, they are pricey, or you can get a potassium carbonate bag, 100 grams from eBay. That is going to be plenty for you. I've used this 600 ml bottle, and all I've done is added about 4.5–5 teaspoons of potassium carbonate into the bottle, and then filled it up with a distilled or demineralized water. So we've got that solution here. So the next step we're going to do is grab the board that has been exposed, a little bit of sticky tape, and that will stick it to the corner, and that'll help us peeling the protective oxygen layer. Next thing, we'll put it in the little container, and we're going to add the solution of potassium carbonate into the container. Now you will notice that the parts that were not exposed will start changing color. They'll become bluish, almost like velvety type. It's doing it right now. And we're going to leave it there for about 1.5 minutes. This is a container with just plain water because we will have to rinse it afterwards. Okay, so it's been there for about 1.5 minutes, and we're going to take out the board out of this developing solution and just place it in the normal water and rinse it off simply by rubbing your hand across it, and as you can see, it already changes the color and you can see the bare copper underneath it. The board turns out to be with a very high resolution. You can do something like Mega 32 or something, AU, or one of those chips. The resolution for them will be just right. So just rub it. Don't use any harsh, like toothbrush or anything really harsh, but you can use a soft brush on it to get all the stuff off. By the way, you can reuse that solution. You tip it back in the bottle carefully, and you can use it for next time. There is no problem. So as you can see, that board turns out to be really good. Every single bit of it. So the next step, we're going to dry it with a paper towel. Oh, tissue in my case, that was closest to me. And it's ready for etching. So here it is. In this step we're going to be etching the board. So I personally use ammonium persulfate. You can be using ferric chloride if it's convenient for you, but ammonium persulfate is pretty good as well. It is clean compared to ferric chloride. So I've got warm water here, well, quite warm, about 75 degrees, 70 degrees, and we're going to be adding to it some ammonium persulfate. Usually you would add in a ratio of 5 to 1. Yeah, so 1 teaspoon of ammonium persulfate to 5 teaspoons of water. So I'm just going to be adding that to the water. It will crackle. And just a little bit more. Now we're going to sway it around to dissolve it. So now all the ammonium persulfate is dissolved in a warm water. We're going to add the board. And usually you would have it agitated, so that means you would have some sort of a swirling and bubbles happening, or also you would have a temperature consistently heated up. You can use something like coffee warmer, USB coffee warmer, or something similar to that, and air compressor going in. That is sufficient enough. I'm sure in the future we will be building a device that would do that all for us. And as you can see, the board is already starting to discolor. That's the ammonium persulfate starting to eat into the copper. So we'll leave that for about 5 to 10 minutes until the board is etched. The board is now ready and etched, as you can see. So the next step would be for us to get it out and rinse it in the water. So we're going to get the board out and stick it into the water and rinse it up. So there we have it. So let's move on to the next step. So in the next step we will be removing the rest of the photoresist that is on the board. For that we will need a stripper solution. Again, you can buy the ready stripper solution, or in my case it's a homemade one. It's a sodium hydroxide, or also known as caustic soda. So what we need to do is to mix again 4 or 5 teaspoons of the sodium hydroxide or caustic soda for 600 milliliters of water. Same thing here. You will have exothermic reaction, which means it will get hot. So just add the caustic soda to 4 or 5 spoons to the bottle and fill it with demineralized water. Don't tighten it just yet, just leave it there and swirl it around for a bit until it dissolves, and it will get hot, so just a fair warning. Once it cools down, your stripper solution is ready, so all you do is add it to your board, to the container, and then pour stripper solution over the top of it. And I'll zoom it in. You will notice it will take a little bit, and all the stuff of the circuit board will just simply pop off. So as you can see, the residual stuff is removed now. You can simply pull it out. The solution can be reused, so we don't want to tip it. So I'm going to take the circuit board out of the solution now. And we're going to place it into the water as well to rinse it. So you can see the board is now really, really nice and clean. So you feel free to pour this rest of the solution. Try to leave all the bits out of the main bottle if you can. If the fuse slip back in, it doesn't really matter. So pour this back, and the step of stripping is now ready. At this stage, you can either continue on with drilling the holes and soldering your parts, or you can go a step further. And let me just clean all this up of the table, and we'll take it to the next step. Now in this step, we will be tinning the board. As you know, copper is very sensitive to touch, so if I were to touch it right now, within half an hour I'll have fingerprints developing on it and it'll have corrosion. So to prevent that, we're going to place it back in the container, and there's a thing that is called liquid tin by MG Chemicals. That will let you tin the board without electroplating. So this is a very toxic solution, so you do have to be really careful and try not breathing it. It even says they're known to cause cancer, so be very careful. And we simply pour it over the board, and up on the contact, as you see, it has already started to tin. So we're going to leave it there for a few minutes. I recommend it about 5 minutes, 3 to 5 minutes. And after it's done, oh, it smells. After it's done, so I might turn the exhaust on too. I will be back. Okay, so the board has been in liquid tin for about 5 minutes now. I'm going to get the exhaust off, and we're going to take the board out and place it in our rinsing water. Make sure you put liquid tin back into the bottle because it's not a cheap solution. So we're going to rinse that, and as you can see, our board is now tinned. Now it appears very cloudy, but you can simply grab a sponge and rinse it with dishwashing liquid, and you'll get it sparkly, which I'm going to go to the sink and do right now. So let me do this, and then we'll move into the next step. The board is now ready and tinted. In the next step, we're going to be applying a solder resist, which is the paste. You can buy it in the syringes. Usually it's sold by syringes, but I've got a tin of it. So we're going to grab something flat and grab a little bit of that green paint. Let's see if I can show you. It's really dark in color, doesn't show up well. And we're going to slightly, just a little bit, apply on the board and spread it around, covering every groove. Make sure it gets into every groove. Don't apply it in a thick layer either. You don't want it to be too thick, otherwise it won't set in places. So just a thin layer all over the board. Spread it evenly. Once you got the whole board covered, grab a transparency film. Just put this aside. Just a clear piece of transparency film. Find which side is a printable one. So the printable side goes up, not down. So if you were to print it, you'd print it on top. So apply that to the board. This is a very tight piece that I've cut. I should have had a bit more. And just using a spudger or anything really, you need to push all the air bubbles out of it. That takes some time, and it's very slow going process. I still haven't perfected it too well, but it's better than nothing. And I'm going to use that to push all the bubbles out of it. So it's as even as you can get, probably. So now we're going to apply the stencil that I have here, again printed side down, line up perfectly, and use a little bit of a sticky tape to attach it to our board. So now let's stick it into exposing unit using a second setting, which is about 5.5 minutes. Okay, so the board has been now exposed, and we're just gonna be careful because on the sides it usually is not set. So we're gonna peel that off carefully. And as you can see, all the tracks that we need exposed are there. So we're going to wipe it clean. Again, watch out for the sides because they are not exposed. I'm going to grab it, but it's going to be messy. So there we have it. The board is nice and clean, and all the contacts are exposed. The next step, we're going to be drilling the holes. There's not many to drill since it's mostly SMD based. So I prefer to use tungsten carbide drill bits. They're very nice. You can buy the whole pack of different sizes on eBay for a very reasonable price, around maybe $3–4. They are very brittle, so any push on it can easily snap it, but yet they're strong enough to drill through textilite and copper and everything. So I usually use drill press at the high speed. You can also use CNC mill to drill it. I've got a small CNC mill, but I haven't set it up yet for PCB drilling. I will be doing that in the future, so it's a lot easier to put that in the CNC, put the board in, press start, and it does all the drilling for you. So at the moment I'm going to be using drill press, which is located in a shed, so I don't have one at the workbench, so I'll have to go and drill the holes. But that's the best drill bits to use for your circuit boards. It's a tungsten carbide drill bits. So let me go and drill the holes in it, and I will be right back. The board is now ready. The holes have been drilled. And just a fair warning, if you're just starting to drill the holes, you're new to it, be prepared that you will be breaking those tungsten carbide bits. They are very, very fragile. If you're using a hand drill, it's straight away, I'm telling you, you probably break the first one as soon as you touch the board. They're that fragile. They have to go straight down, and they can't have any lateral movement. They're very, very brittle. So anyway, the boards are done and the board is ready for population. So let's get to the next step, and I'll show you a few techniques you can use to solder SMD components into the board. So obviously the big ones that are through hole, you would have to be using your soldering iron. But for SMD, there is a different technique that you can use. Okay, so now we're going to be soldering using hot air gun. For this you will need a soldering paste, which is this type. It comes in a little tin. And what we're going to be doing is just grabbing, it's on a preheat to 150 degrees, so it's actually maybe about 70–80 degrees to touch. So we're going to grab a little bit of our little goo, and we're going to tap the points where we're going to be soldering the components. Okay, once we've done that, next step will be placing the components on their dedicated spots. Alright, so now that they're placed, we are going to get our soldering gun or heat air gun and just start slowly heating up the board. Set the temperature to around 270, and progressively airflow is probably to quarter, and slowly start heating up the board. Okay, I have inserted the through-hole components, which is a capacitor, a couple of DuPont connectors, rising clamp connector, and a few jumpers. And now we're going to solder them on. So I strongly recommend using RA-type flux. This is a really great flux. Again, MG Chemicals sells them. Just acquired a few drops, and it does magic. It literally solders the stuff that is unsolderable. It's that great. So a few drops around the contacts. How about those ones? Even the the old wires that are rusted out and they do not take solder at all. Drop of that and they will. Not that you should do that. You should probably replace the wire if they're that bad, but that's how good the flux is. So simply just solder. So a tip when you're soldering, do not carry solder on the soldering iron. Clean it regularly. So apply the soldering iron to the connector and then touch with the solder until it's melted, and then take the soldering iron away and dip it in a flux paste. Then let's cut all the excess off. And personally, I always like to get a bit of a flux on the tip of a paste and just touch up to those points where it just snapped off. That'll make them nice and smooth. So the next step is cleaning. Always you have to clean the flux. It is a must. So as you can see, let's see if I can see that little ball here? That is stuck there. And if the board gets hot and the ball starts rolling around, it can short stuff out. So you really want to clean the flux. Use just a thinner, paint thinner, that's what I use. Don't be afraid with the amount, just drown the board with it, it'll be fine. And using a cotton bud, just start cleaning around the contacts until you get all the flux and all the residue out of it. So I'm just going to do this for a while and be a bit of OCD with it, and once I clean it all off, I will return with the result. The board is now clean and ready, as you can see. So the next step is, well, usually you would lacquer the board as well, but in our case we're going to test it first. So I've applied 12 volts. I've actually done this board before. It's for the car, so it's using to turn the accessories on and off with a press button in the car, and it runs just fine. So I've got two LEDs here because it's a dual channel. I've got a 12 volt supply. So let's turn it on. And as you can see, the LED is lit, so the board is on. And now we'll try shorting out as if it was a button. And yes, 1 and 2. Very decisive. So it works just fine. And the thing is, if you turn it off from main power, up on power on, it will stay in an off state, as you can see. So this is a great board. Anyway, now it is time to cut it to size and lacquer it. This is the lacquer that I'm usually using. It's especially designed for circuit boards. So I'm going to spray this side and let it dry quickly. And after masking this side, I usually spray a little bit on here as well, just to protect all the jumpers and wiring, since I did design this for the car. So that's ready now. Just let it dry and then I'm going to cut it out. As you can see, the board is now fully completed, fully functional, and it's lacquered and cut to size. So this is the great result. So thanks for watching this video. I hope it helped you with your own circuit boards and hope you enjoyed it. Don't forget to like, subscribe and comment. Thanks for watching. I'm Max. Bye.